Okay, so welcome to the lecture 3 session of these tutorials. Okay, so we'll just basically do the solutions to systems of linear equations, and then we'll do nonlinear equations in the next session. Okay. So first of all, let's just revise the idea of vectors. So what is a vector? A vector is simply a one-dimensional array number. So we can have vectors in different forms. So we can have column vectors like that, and we can have row vectors like that. Okay. So maybe 2, 3, 2 something, 0, 1, 2. Right. Then these are both vectors. Right. So we have the idea of vectors already. So let's just move on to the next thing. We'll also talk about matrices, right? So a matrix is simply two-dimensional, three-dimensional, whatever array of numbers, right? So if you have like a 2 by 2 matrix, 3 by 3 matrix, they're just arrays of numbers. So a combination of vectors can give you a matrix. Okay. So if we have two equations like that, we can always convert that to a matrix form that can look like 1 1, and then 1 2. So this method is it's always better to use this because like this is the augmented matrix form, augmented. So it's easier to work in this form. We'll show you that later on. Okay, so we have identity matrices. So if it's an identity matrix for 2 by 2, then we have something like this, right? So this identity matrix for 2 by 2. If it's 3 by 3, then the idea of identity matrix is simply the magnitude. The magnitude of identity matrices is just 1. Okay. Yeah, so this is an identity matrix for a 3 by 3. Okay, so let's just move on to the next thing. Okay, so we met some of this stuff. We say, let's say something has infinite solutions. We have inconsistent, right? So inconsistent, yeah, and then we have unique. So if you write a matrix now, these are the 3 kinds of solutions you can have. You can always find that in the slide too. Yeah. Okay. So here, right. So solutions to, you can always have a unique solution, an infinite solution, no solution. So let's just explain. So what does it mean to have an inconsistent solution? You remember what we spoke about in precision and accuracy when we say okay, so when we say something is inconsistent, then that means repetitively just keeps on saying different things, right? So let's say I tell that okay, x equals 3, and then for the same question I tell that x equals 2, then these are inconsistent. But then let's do it in the idea of matrices, get it more. So here we have 2x1 plus that equals 5, and this equals that. At the first glance you might think they're different equations, but then let's simplify it. So this one, we know that it's the same thing as x1 plus 2x2 equals 5 on 2. That's if we decide to divide through by 2, then we have this one again. Okay, so this one does not change. Now with this, we can clearly see that we are saying that x1 plus 2x2 is 5 on 2. At the same time, we are saying x1 plus 2x2 is 3. This is inconsistent, right? So we say inconsistent. So you don't have the same thing. Now, if we say it has infinitely many solutions, then once again, let's always try to break them down. If you look at this, okay, so we have just this, okay. Now let's try to break it down, and then this equation 1, equation 2. But then let's look at this equation 2 really carefully again. Sorry, this x1. We'll have divide through by 2. You realize that you land at exactly the same equation here. Okay, so realize that they are not two, actually they are not two equations, they are just the same equation. So it has infinitely many solutions because for any value of x1, so let's say if I take x1 to be s, I'll always get a corresponding x2, right? So we say they have infinitely many solutions. You can always find solution for, yeah. And then another way of solving, so the ways of solving numerical equations or something is you can always have graphical solutions, you can always have analytical solutions, right? Yeah, and you can have numerical solutions as well. So for this one, okay, so for a graphical solution, we know how to do that. So let's say you have some sketch, right? And then you want to find the solution for some two equations. So let me do this. Okay, so this one can be y equals x squared. Okay, just presumably. And then we have another equation, maybe y equals x plus 1. Okay, let me see how I'll draw that. That will look like this. Okay, so if you have these two equations, you can always solve them graphically by I think this is, yeah, that's fine. So you can always solve these two equations graphically by checking the intersection points. So every intersection you just trace down, that's a solution, that's a solution, as simple as that. So that's all for the graphical method. Okay, so let's go more to the linear solutions or linear equations. It's easier to solve linear equations using matrix methods, right? Yeah, because matrices are easier to manipulate. And then we can also use the calculator for that. So okay, so first of all, if you have okay, so let me see, I was supposed to show you something. Okay, so let me just show you how to find the determinant of a matrix with the calculator first. I think finding it with calculation is quite easier. So let's do how to find the solution of a matrix, the determinant of a matrix using the calculator. So over here, so once again, before you start, you can just clear everything. Okay, now, so if you check here, right, and check here, or you see matrix, and then when you go for mode, you see matrix number 6 too. So you just come for number 6, then go for number 1. You can go for matrix A, matrix B, matrix C. So let's say I go for maybe a 3 by 3 matrix. Then I have to enter my figures. So let's try something new. So 3 minus 1. So when you just press your number, just press equal to it to just save it. 0 and then 5. Right, and then we have negative 1, 5, and then 4. So you can just press equal to, you can leave it like that. So using the calculator really saves time. Then you come to and do shift matrix, right? So you can find that to data 1. So when you check, this is just to tell us that okay, the data we saved, right, the data we worked on is still in the calculator, so you can just press AC. So that's fine. You don't need to do that latter method. So you do shift again and 4. Now you realize that you have access to a lot of stuff, right? So dim okay, so this dimension, data, matrix 1, matrix A, matrix B, matrix C, matrix answer. That's for matrix calculations, like if you add a matrix and all that. Depth, that's determinant, and then transpose of a matrix. So 7, so come to 7, and then now we come for shift 4 again. What was the matrix you see? That was matrix 1. Then we come to 3. So we are finding the determinant of matrix A. Then we press equal to. Then we have negative 82. Then come here, right? Negative 82. So instead of doing that long solution, you can always do this. This saves you a lot of time. You don't have to calculate. Okay. Let's assume we had let's assume another thing again. So let's say we create another matrix. So let's create matrix A, maybe 2 by 2 to make it easier. So maybe we create 2, 3, 5. These are just random numbers. Okay. And then we want to create another matrix again. So come to matrix. Okay, so data 2. Then we create another matrix again. So let's come to 2. Then we say okay, we want to create a 2 by 2 matrix. Let me say 4, 1. Okay. then we're done with this one, right? Then it will be saved, so you can just press it, AC, and come to matrix again. Then we can take, okay, matrix 1 times, and we can come this again, a matrix what? That's matrix. Okay, so we can find it. So realize that they have so if you multiply them, they'll give you that product. Okay, so multiplying two matrices has been made easier. You can go back, alright, you can go back and do matrix 3 plus matrix B, right? You can do this too, and then you get your matrix again. Yeah, so these are like easy ways of solving for matrices. We'll use them when we move on to the next thing. Hope you understand. Okay, so let's get to the next thing for today. Okay, so using the graphical the numerical methods, we are just going to consider some two forms of solutions here, maybe three. So we'll do um okay, so we'll do the naive Gaussian elimination method, and then we'll also do the, I don't know if we should do it, but then let's see. And then we'll do the Newton's method too. Okay. So let's get to it. Yeah, so this is an augmented matrix, 3 by 3 augmented matrix, so you just have to separate it with a line. And then we come to naive Gaussian elimination. To solve naive Gaussian elimination, right, to use this method, this is quite simple. There are two steps, right? We have forward elimination and backward substitution. You don't have to remember this. So here we have a matrix. That's just what I showed you earlier. So let's say they give you three equations with three unknowns. So we don't know x, y, z, and we're trying to find x, y, z with this. Okay, then so what do we do first? So the idea is that we want a lower triangular matrix. Okay, so we want the lower part, like the lower part of the whole matrix to be 0. So we want here to be 0, we want here to be 0, we want here to be 0, we want here to be 0. Because if those places are 0, we can just say that z equals that. So x times 0, y times 0, those go away. So you can just say z equals this, and then we substitute z back here, substitute y and z into this, and we find x. That's what they call backcross substitution. Okay. So now first of all, let's start. So how do we make this 0? We can make this 0 by adding 1 to that. So that's sorted. So that means that we just have to make sure whatever we do to these two affects everything else. So we just add, right? So we say, okay, first of all we do r1 plus r2, then 0 comes here. Now negative 2 plus 3, right, that gives us our 1, and then okay, that gives us our 1, and then we have 3 plus this, that gives us our 4, this plus this, that gives us 7. So we can just put that inside. Now over here, how do we get 0 for this? So first of all, let's find zeros for these. So 0 for this, then we can say that, okay, we can take negative 2 times r1 plus this, or we can say r1 minus, or 2 times r1 minus r2. But then for easier, to make it more safe, always just make it this way. So you say 2 times negative 2 times r1 plus r2, and just do that. So here negative 2 times this is negative 2, 0, right? So this goes to 0. Negative 2 times this, that gives us 4, and then 4 plus that gives us negative 1, and then 3 times negative 2, negative 6, negative 6 plus negative 6 plus that gives us negative 1 again. Okay, so that's fine. And then for this one, right, we can do the last one we done. So negative 2 times 9, that gives us negative 18. Negative 18 plus that gives us negative 1 again. Okay, so this is pretty simple, right? Now we come to the next thing. We want to apply another function or operation on these two to just reduce one of them to 0 now. So we have this, so we won't do anything to this. Now we just want this one to also be 0. So what do we do? On the first glance, we can simply say this one plus this, and then we have that. Okay, so we can just say R2 plus R3. So we can just leave them. So this will be 0. This plus this. So right, this plus this, that gives us 3. That plus. So we just add these two, just 6. Then we are done with this. Okay. So this is naive Gaussian elimination, and then okay. Okay, so what do you? There are many ways you can move on from here. So you can simply say that okay, since this is z, we can rewrite our whole equation again. So we have x plus negative 2y. Oh, sorry for that. Plus 3z equals 9. Then we have 0 times x, that gives us 0. So we say y plus 4z equals 7. Right? And then we have 3z equals 6. So you can, the best way to solve this is start from the bottom. So we start here. So that gives us z equals 2. Then we put 2 here, right? So that gives us 8. So that gives us y equals negative 1. And then we can put negative 1 here, that gives us 2. And put 2 here, that gives us 6. Right? So what do we do? 6, so that gives us x equals 1. Okay. You can always solve those ones. I'm sure you most likely get the same thing. Okay. Yeah. So this is just all for it. So that's just all for naive Gaussian elimination. It's not anything big. Yeah. Okay. So you can also do the Gauss-Jordan elimination. That is also relatively simple. Say Gauss-Jordan. Gauss-Jordan elimination. To do the Gauss-Jordan elimination, you just have to do the same thing. Okay. So when you get here, you have to start making everything here 1 and then everything here 0. So let's try. It's not so important, but then let's try. Okay, so here you can simply divide here by 3, so that gives you 1, right? Or you can use okay, so let's just do it. Okay. 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 Okay, so let's get through this one. So we want to do Gauss Jordan on this. Okay. So first of all, we can use this to reduce these things to 0. So how do we use this to reduce that to 0? There are many ways to manipulate this. Then we can say okay, this one, right, minus this, and we put it here. Simple. So let's try. So we are going to do this line minus this. Why are we doing that? Because this 3 will actually go away. Okay. So we start. Okay. So let's do that. So we have 1 minus 0. That gives us 1. Negative 2. That gives us 0. Okay. And then 9 minus this. That gives us 3. And 0. You can maintain this one, or you can also reduce it. Okay, so let's reduce that too. So to reduce this one, you just have to know how to manipulate this stuff. So we can always multiply here by this one. We can multiply this one by maybe 3 or 4. I mean that whole this one, and multiply this one by 4 and 3. Right. We are just doing that to make sure that, so if you do this one, we get 12. Okay, we get 4. That's what it says. So we get 4, we get that. Okay. So here we can do that. So meaning this time this gives us 3. This time this gives us 4. Okay, we don't get nowhere. So let's just multiply this one by 3, multiply this row by 3, and multiply this row by 4. Okay. So if we multiply this row, by 3, then that means they'll end up having 3 here, and then we'll have 12. So this 12 can just leave it. Okay, so let's just write it so that we don't confuse ourselves. 12. And then 0, 0. Multiplying this side by 4, we have 12 again, and we have 24. Okay, so I guess you are seeing how things are turning out now. So we can always do subtraction between these two again. Then we can have 1, negative 2, 0. And we have 3, 0, 3. So this minus this, that gives us 0 and 21. Okay, 0, this minus this, that gives us 3 again. Alright, and then we have 0, 0, 12, and then okay, 24. Okay, okay, I want to be sure we didn't make any mistake. So this minus this minus that. Okay, very cool. Okay, so let's do the let's get to the last one. So how do we take this one to 0? Right, you can multiply this place by 3, multiply this place by negative 2. Okay, so oh, I didn't save space for that. Okay, so let's do that here. Okay, so if you multiply this side by 3, you end up having 3 here, right? Then you have negative 6, and then here you have negative 6, so you know that they will definitely cancel out. So you can just put that 0 since you're adding them. So let's say this one minus that, and you put it there, and then we have what do you get here? So this one comes to 0 again, and come to 3, and then okay, so this one comes to 0. Then you can just leave this one as it is, and then 0, 0, 12, then 24. Okay, so mm, okay, so I just noticed something here. So we did some subtraction here. This minus that gives us minus 3. So you might just like to make that correction. Sorry for that. So you have negative 3 here, which means we also have negative 3 here. So you can now break this thing down to 0. You can break to 1, sorry. So here you can just divide the first row by 3. That gives you 1, 0, 0, 1. This gives us 0, 1, 0, negative 1, and then 0, 0, 1. You can divide this by 12, okay? Then you end up having 2. So realize that you end up having x equals, so x equals 1, y equals negative 1, and then z equals 2. Yeah, so this is just like, it's probably a longer way, but then it still solves the problem, okay? Yeah. But then I would recommend that if you are for the purpose of exams, you can just stick with one method, and naive Gaussian elimination is fine. And then the LU decomposition is just another useless method. Yeah. So you just don't have to do all of that. Since it's going to be objectives, you have the option to just do one method and then you get your answer. And then even these stuff you can still do them with the calculator. So here let's do it with the calculator too. So if they give you this, you don't have to start doing naive Gaussian elimination. um, Time will be all gone. So let's get to the calculator. So we're going to solve this equation with the calculator. Come to equal to equations 5. Okay, so if it's 3 by 3, okay, so if it's 3 by 3, you can do that. I don't know if, let me see if there's an option for 4 by 4. Okay, so there's an option. Okay, so let's start. So here we just put in 1, negative 2. One thing about using the calculator is that you just have to be more careful with how you do your typing. That's the only way you can get an error. And then z is 1, and negative 2, and then 2, negative 5, 5, 17. So you see, just there, in less than a second, we have x equals 1, we have y equals negative 1, we have z equals 2. So you see that it's It's not necessary to do all of this, right? Yeah, so you can simply do that to your calculator and you have your answer. It's objective, so you don't have to solve it. And then he can't give you 5 by 5 matrix too. That will be okay. If he gives 4 by 4, then you have to solve by then. Yeah, so that's fine. Yeah. Okay, so this is a 4 by 4 matrix. You can just take a snapshot of it and then try it on your leisure time or something. So, I don't know if we should go through it. Okay. Okay, so with this one, okay, so I'll just give you a blueprint on how to go around with it, and then you can just do it on your own. So first of all, we need to get all of these to 0. So how do we do that? So first of all, for this one, you can clearly see you can multiply this one by 2, subtract this one, then we'll have our first line. Okay, so always pay attention to these ones. So here, so for the first one, so let's say for first, I'll just give you the blueprint. So here we have negative 2 times r1, and then plus r2, and then for here we say r1 negative r1 plus 2 times r2. Okay, and we can say r1 plus r2. Then you do this. Okay, so when you do this, everything here will end up as 0. Then you do second. So these are just like blueprints for you how to continue. Now with the second one, that will depend on the values you have inside here. Okay, so depend on the values you have inside here, then so you maintain this one, then you just have to eliminate these two. So you have like second, third, and then fourth, and you'll be done, right? So you have to pass this before you know how to do that. But I'm sure that with the idea of how to do this stuff, you should be able to solve a 4 by 4 matrix. Okay. And if it brings a 3 by 3 matrix or 2 by 2 matrix, don't solve it at all. Just put in the calculator and pick your answer. Okay. So I think this is basically all for lecture 3. That's all for lecture 3.